So welcome to session 7 of the Pre-Leaving Cert Algebra Revision course. This session is going to take a look at manipulation of formula. So these are questions where we're going to rearrange a formula that we've been given to get a particular letter by itself. So that letter then becomes the subject of the formula. It brings together lots of stuff that we've looked at in previous videos. For example, simplifying expressions, expanding brackets, factorizing, solving linear equations, finding common denominators to simplify fractions. All that kind of stuff is rolled into this particular topic. We're going to look at 10 basic examples, so each one, as usual, slightly different than the previous one, so we can kind of build up our knowledge as we work our way through them. And then we'll have 10 trickier examples. Some of the examples have been taken from Leaving Cert higher level papers, where we have adapted some of those questions to make it relevant to this particular topic, and we can see the importance of manipulating formula moving into Leaving Cert. And then finally we have the large bank of past questions and work solutions from Leaving Cert and Junior Cert papers that people can go and have a look at if they want to practice any of the particular types of questions. So as we jump into our very first example, the key thing to stress is that once we've been given a formula, and a formula is just an equation, it has an equals in it with some letters on the left hand side and some letters on the right hand side, we're allowed to do whatever we like to this equation, as long as whatever we do to the left hand side, we do the exact same thing to the right hand side. And that's going to be the guiding principle throughout all of these questions. So let's write down the first equation that we've been given, which is that 4x minus 7y equals 2z. And so we've been asked to express x in terms of y and z. So we're making x the subject of this formula. And so we're trying to get x by itself on one side of the equals. So the first thing I'm going to do is I'm going to have a look at the left hand side where the x is, and I can see that I have a minus 7y on the left hand side. And so the first thing I want to do is get rid of that minus 7y. I want to collect the y terms on the right hand side. And what does that mean? That means adding a 7y to both sides. So if we add a 7y to the left hand side, minus 7y plus 7y is 0, and that gets rid of the minus 7y. And if we add a 7y to the right hand side, I'm left with 2z plus 7y. The next step is I want to get x entirely on its own. So much like a linear equation, we're going to divide both sides by the number next to the x. And the number next to the x in this case is 4. So I'm going to divide both sides by 4. So 4x divided by 4 is 1x. And then we have 2z plus 7y over 4. And so we've got x entirely by itself. We've expressed x in terms of y and z. X is the subject of this formula. So writing down question 2, we have 2a on 3x plus 4 equals 7, and we're asked to express x in terms of a. So we're trying to get x here by itself, so to make x the subject of the formula. It's within a bracket, and so the very first thing we want to do is get rid of the brackets through multiplication. So we're going to do 2a times 3x is 6ax, and then 2a times 4 is 8a, and then this is going to be equal to 7. So remember, when we have a bracket, what we do is we multiply the term outside of the bracket by all of the terms inside of the bracket. We're trying to get x by itself, so we want to get rid of the plus 8a that's beside it on the left hand side. To get rid of a plus 8a on the left hand side, we'll subtract an 8a from both sides. So if I subtract an 8a from the left hand side, I have 6ax, and then 8a minus 8a is 0. And then if I subtract an 8a from the right hand side, I have 7 minus 8a. Finally, I want to get the x by itself, so I'm going to divide both sides by the term next to the x, which is 6a. So if I divide 6ax by 6a, I'm left with x. And if I divide 7 minus 8a over 6a, I just get 7 minus 8a over 6a. So you'll notice that when I've worked my way down through the sum, I'm talking about adding a term to both sides, or subtracting a term from both sides, or dividing both sides by a particular term. Sometimes when we're doing the question, we will hear language like jumping over the equals and changing the sign, or dividing underneath by a term. And those kind of things are fine. I've used that language sometimes myself. But just to be aware that we're actually doing something to both sides. We're changing both sides of the equation to keep it the same. Subtracting an 8a from both sides means that we're subtracting 8a from both sides. It's just that we don't always write down this minus 8a on the left hand side. We kind of talk about it jumping over an equals and changing sign. So in example 3, we have a fraction in the question. We're given that b is equal to a minus ct over 2. So as when we had brackets in a question, we wanted to get rid of the brackets. If we have fractions in a question, we also want to get rid of the fractions. So the way that I'm going to get rid of the fractions is I'm going to multiply both sides by 2. Now generally I don't write it like this, but we'll just do it for the first example. I'm just going to put a 2 by both sides so we can see exactly what I'm doing in a question like this. I'm multiplying the left hand side by 2, which gives me 2b. And then if you multiply the right hand side by 2, the 2 above and below the denominator, they cancel. You're dividing above and below the denominator by 2, and so they're gone, and you're left with a minus ct. So sometimes what we talk about is when we're multiplying both sides by the denominator of one of the terms, that 2 is just going to get multiplied up on the other side. So to me, that was the handiest thing to do in this particular example. We could have put the b over 1 and found a common denominator of 2 and then dropped the denominator when we went to the next line, or we could have cross multiplied as we've seen in previous videos as well. So in this example, the handiest thing to do was just to multiply both sides by 2, and then on the next line we can see that the left hand side becomes 2b, and then the 2 cancels on the right hand side to give us a minus ct. We're trying to make t the subject of the formula, so to get t by itself, and because it's a minus ct, I think I'd like to collect the t terms on the left hand side of the equation, and what that's going to mean is adding a ct to the right hand side to get rid of it from there, and if I add a ct to the right hand side, I'm going to add a ct to the left hand side, so I'm going to have ct on the left hand side. I only want t terms on the left hand side, and so I'm going to bring the 2b to the other side. And how do I do that? I subtract a 2b from both sides. If I subtract a 2b from the left hand side, it's gone from the left hand side, and then I have to subtract it from the right hand side also to give me a minus 2b. We're trying to get t by itself, so I'm going to divide both sides of the equation by the term next to the t, which is c. So we have t is equal to a minus 2b over c. So let's just quickly have a look at if we had found a common denominator, because we're actually going to use the common denominator method in the next example. So b over 1 is equal to a minus ct over 2. I'm going to find a common denominator which is the lowest number that 1 and 2 go into, which is 2. 1 goes into 2 2 times, and I need to multiply that by b, equals 2 goes into 2 1 time, and I have to multiply that by a minus ct. Because all the terms are over the same denominator, we can drop that denominator too, and we're left with 2b is equal to a minus ct. And in this example, what I'm going to do is I'm going to keep the t on the right hand side to show you that we do actually get the same answer regardless of what side we decide to collect the term we're trying to get by itself. So that means I'm going to get rid of the a from the right hand side, so I'm going to subtract an a from both sides. So I have 2b minus a equals minus ct. And then finally, I want to get rid of the letter that's next to the t, which is minus c. So I'm going to divide both sides by minus c. And I get 2b minus a over minus c is equal to t. Now you might say that that looks different from the answer we got previously, but they're actually the same answer. So just to show that they are the same, 2b minus a over minus c. I'm going to factorize a minus 1 from the top. So I'm going to take out a minus, and that would leave me with a minus 2b plus an a inside the bracket. And just to test that, minus 2b is plus 2b, minus plus a is minus a. So I haven't changed the sum, I've just factorized the minus to change the look of it, let's say. And on the bottom I'm going to factorize a minus, so I'm going to take a minus out of the minus c, and I'm left with just c. I have a minus over a minus, and a minus divided by a minus is a plus, so they cancel. And I'm left with minus 2b plus a over c. And well, saying minus 2b plus a, that's the same as saying a minus 2b, and then obviously that's over c. And so you can see we do get the same answer as we did in the first one, and I just rearranged it because I didn't like to have a minus on the bottom of a fraction. And so that just emphasizes the importance of bringing the t term to the side where you know it's going to be positive. It's something you don't have to do initially, but then later on in the question, if you have a minus on the bottom of a fraction, it is a good idea just to change that around by factorizing out a minus out of the top and the bottom, and it will leave you with the same answer as we got had you brought the t's, let's say, to the side where they would have been positive. So the reason we looked at the common denominator example in the previous question is because this question involves us finding a common denominator to get rid of the fraction. So we have 3 terms here, and so I can't cross multiply, and we could multiply across by a particular number which we look at the end. But I think the easiest thing here to do is to actually find a common denominator. I'm going to put the 5a over 1 just to make it a fraction, and then I'm going to draw a line across the width of the sum and find a common denominator. The lowest common denominator is 12, so 1, 4 and 3 all go into 12. 1 goes into 12 12 times, so I need to multiply the numerator 5a by 12, equals 4 goes into 12 3 times, so I need to multiply the numerator 3b by 3, plus 3 goes into 12 4 times, so I need to multiply the numerator c by 4. So because all the terms are over the same number 12, I can cancel the 12 and just form an equation with the numerator. So 12 by 5a is 60a, equals 3 by 3b is 9b, plus 4 times c is 4c. Now we're trying to find c on its own, so c is going to be the subject of the formula. So I want to keep the plus 4c on the right hand side, which means subtracting the 9b from the right hand side. If I subtract 9b from the right hand side, I also need to subtract 9b from the left hand side, and we're left with 60a minus 9b equals now just 4c on the right hand side. I want to divide both sides by the number next to the letter we're looking for, which is c. So I get 60a minus 9b over 4 equals 4c over 4 is just c. So we've made c the subject of the formula. So what we could have done initially was we could have spotted that we just multiply everything by 12. If we multiply the first fraction by 12 and the second fraction by 12 and the third fraction by 12, we'll be able to skip straight to this line here. So it's something that some people are comfortable with doing. Other people like to find the common denominator first. Let's just have a look at how that would work. So we can divide the 1 into the 12 and get 12 times, and times it by 5a to give us 60a. We can divide 4 into 12 to give us 3. 3 by 3b is 9b. And we can divide 3 into 12 to give us 4, and 4 times c is 4c. So again, it's a personal preference what people like to do. Note that in this one we just couldn't have cross multiplied because we had more than one fraction on each side. But whether people want to multiply every term in the question by a particular number and skip a line, or whether people want to find the common denominator, both methods are fine, and you'll kind of find what's comfortable for yourself. So example 5 is similar to an example we've seen previously, but just with an additional substitution step at the end. So the initial part of the question is to get x by itself. So we want to express x in terms of the other letters in the question, p and t. So I'm going to keep the 3xp on the left hand side, and I want to get rid of the minus 5t, so I have to add a 5t to both sides. So we get equals 7p plus 5t. I want the x on its own, so I need to divide by anything that's being multiplied by the x, so 3p. So if I divide the left hand side by 3p, I just get x, and if I divide the right hand side by 3p, I get 7p plus 5t over 3p. The second part of the question then said to find the value of x when t is 4p over 5. So I'm just going to write down my new equation again. So x is equal to 7p plus 5t over 3p. And I'm just going to sub in a value for t. I've been told that t is 4p over 5. So x is equal to 7p plus 5 times 4p over 5 all over 3p. So x is equal to 7p. Now 5 times 4p over 5, well the 5's will actually cancel there, or we could say 5 times 4p is 20p, 20p divided by 5 is 4p. And then that's all over 3p. Tidying up the numerator, I get that x is equal to 7p and 4p is 11p over 3p. And finally, there's a p above and below the fraction, and so I can cancel that p, and I'm left with 11 over 3. So example 6 is the first example where we have a square root. So we have p is equal to the square root of 2q minus r. And so the first thing I want to do is I want to get rid of the square root from the right hand side, and so I can square both sides. If I square the left hand side, I just get p squared, which is p squared. And then we'll remember the rule of surds that if we square a square root, we just get the term or terms underneath that square root. So that's 2q minus r. So it's sort of like the square and the square root cancel each other. So we want to write r in terms of p and q. So I can see it's a minus r on the right hand side. And so if I add an r to both sides, it will get rid of the r from the right hand side and put a plus r on the left hand side. I want to get rid of the p squared from the left hand side, so I'm going to subtract a p squared from both sides. So the right hand side now has 2q minus p squared, and that's our final answer. We might just explore what would happen if I kept the r on the right hand side in this question. So on the left hand side I would have had p squared. I would have got rid of the 2q from the right hand side, which means subtracting a 2q from both sides, and that would be equal to minus r. So we weren't trying to make minus r the subject of the formula, we're trying to make plus r the subject of the formula. So I'm going to multiply the left hand side and the right hand side by minus 1. If I multiply all the terms on the left hand side by minus 1, I get minus p squared plus 2q equals plus r. And then I'm just going to reverse the order of these so they look like the other one. So minus p squared plus 2q is the same as saying 2q minus p squared, and that's equal to r. And note that that's the exact same answer as we would have got in the first case. But again, by bringing the r to the side where it was going to be positive, I didn't have to worry about further tidying up near the end to make it a plus r. Okay, so in example 6, the letter we're trying to get by itself, u, it has a square on it. It has a power on it. So let's have a look at what happens when we have a power in a question like this. So we have 2u squared minus v equals w, and we're trying to get u by itself. So the first thing I'm going to do is I'm going to get rid of the minus v from the left hand side. So that means adding a v to both sides. If I add a v to the left hand side, it gets rid of the v's on that side. And if I add a v to the right hand side, I'm left with w plus v. Next, I want to get u by itself, so I'm going to get rid of any number that's directly beside it. So 2 is being multiplied by u squared, so I'm going to divide both sides by 2 to get the u on its own. So I have u squared equals w plus v over 2. So dividing 2 on the left hand side gets rid of the 2, and then dividing 2 on the right hand side we have w plus v over 2. So I'm not trying to make u squared the subject of the formula, I want to make u the subject of the formula. And so what I'm going to have to do is I'm going to have to find the square root of both sides. The square root of u squared is u, and then the square root of w plus v over 2 is just root w plus v over 2. Just to have a look at what if that had been, let's say, an x cubed equals w plus v over 2. Just to have a look at what would happen if it was a cube instead of a square. So here the square root of both sides wouldn't have been enough. We would have to get what's called the cubed root of both sides. The cubed root of x is just x, and then we'd have to write the cubed root on the other side. And the way we write a cubed root is we put a little 3 just at the top left of the surd there, like that. And you can do this with any power. So let's say we had y to the power of 5 was equal to w plus v over 2, and we're trying to get y by itself. Well, then that would be the fifth root. So if we got the fifth root of y to the power 5, we get y, and then we get the fifth root of w plus v over 2. Example 8 is another example of a question with fractions in it. So we have a is equal to 2r squared over x plus y. So as we saw in some of the previous examples, the easiest thing to do here is to multiply both sides by the denominator of the fraction. So that's x plus y. So if I multiply the left hand side by x plus y, I have a on x plus y equals, and if I multiply the right hand side by x plus y, that cancels the x plus y, and we're left with 2r squared. So we can find a common denominator, we could cross multiply, but hopefully people can see the kind of shortcut here in terms of just multiplying both sides by the denominator of the fraction we have, and we get a on x plus y equals 2r squared. I'm trying to get y on its own, so I'm going to multiply out the bracket because y is contained within that. So I have a by x is ax and a by y is ay, and that's equal to 2r squared. I only want y terms on the left hand side, so I'm going to subtract an ax from both sides to leave me with ay on the left hand side, and then on the right hand side I have 2r squared minus ax. And finally I'm trying to isolate the y, so I'm going to divide both sides by the term or number beside the y, which is a. So y is equal to 2r squared minus ax over a. So just be aware that you might see solutions sometimes where the fraction has been split. So if we were to split the fraction, I can see that we'd have 2r squared over a minus ax over a. So to simplify this further, we could say y is equal to 2r squared over a, and then we can see that there's an a above and below in the fraction here, so we can cancel those just to leave us with an x. Both these answers are absolutely fine, and these solutions are equivalent to each other. They both express y in terms of a, x, and r, and it kind of depends on what you're going to use this value for y in a further part of the question, or if you're going to use it at all. If you weren't going to use it for anything else, you may just decide to leave it as it is on the left hand side, and depending on whether there's something else that you have to do with it, you might decide to split it up as two separate fractions. So in example 9, we have brackets on both sides of the equals, and we're going to see that in this question we have to use factorizing to express y in terms of x. So we'll see how that works. Let's write down the sum first of all, which is 2 on 3x minus 5y equals x on 2y minus x. So we're going to multiply it out to get rid of the fractions. 2 by 3x is 6x, 2 by minus 5y is minus 10y, equals x by 2y is 2xy, and then x by minus x is minus x squared. I'm trying to get y on its own, so I'm going to bring all the y terms to the right hand side so that they'll be positive, and I'll keep the other terms on the left hand side. So I have 6x already on the left hand side. Minus x squared doesn't have a y in it, so I'm going to add an x squared to both sides, and it becomes 6x plus x squared on the left hand side. I'm going to add a 10y to both sides to get rid of the minus 10y from the left hand side, so I have 2xy plus 10y. Now, this is the first question where we're trying to get a letter by itself, but there's two occurrences of this letter. We have a y in both 2xy and in 10y, and so the question is, how am I going to get y by itself if there's two of them in the question? And this is where our factorization comes in. So what I'm going to do on the left hand side is just write down 6x plus x squared, and then I'm going to use common factor factorization to take out y from the two terms. So if I divide 2xy by y, I get 2x, and if I divide 10y by y, I get 10. And just to check that that's the correct factorization, y times 2x is 2xy, y times 10 is 10y. Now finally, I'm trying to get y on its own, so you have to divide by the term that's beside the y. 2x plus 10 is being multiplied by y, so if I divide both sides by 2x plus 10, I can get y on its own. So on the left hand side now, I have 6x plus x squared divided by 2x plus 10, and then obviously dividing the right hand side by 2x plus 10, I'm left with just y. So first question where we've seen some factorization, we'll have another example of that in question 10. And just to be aware that if you have two occurrences of the letter that you're looking for, you may have to factorize before you can get that letter by itself, or make that letter the subject of the formula. Example 10 says that if 2 over x equals 5 over y minus 7 over z, express z in terms of x and y. So we're trying to get z on its own in this question, make z the subject of the formula. I'm going to find a common denominator, and the common denominator is the product of the denominators of all the fractions. So x by y by z. If I divide x into xyz, I'll be left with yz, and so I need to multiply the numerator 2 by yz. Equals, if I divide y into xyz, I get xz, so I need to multiply the numerator 5 by xz. Minus, if I divide z into xyz, I get xy, so I need to multiply the numerator 7 by xy. Because all of the terms are over the same denominator, xyz, I can get rid of the denominator. And just to give us a bit of space, we'll write down the top line over here. So 2yz is equal to 5xz minus 7xy. So the first step was just to get rid of all the fractions. Now, as in the last example, there's two occurrences of the variable that we're trying to get by itself, z, and so what we're going to have to do is collect them on one side and then factorize. Now, it doesn't really matter which side we decide to collect them on, but because there's a minus 7xy that would be on its own when we collect the z's, I think I'd be inclined to make that a positive number so that we don't have minuses in our final answer. Again, it's not terribly important, but I'm just going to collect the z's on the right hand side of the equals and the other terms then, the minus 7xy on the left hand side. So to get rid of a minus 7xy from the right hand side, I'm going to add a 7xy to both sides. And then that's going to be equal to 5xz, which is already on the right hand side. And then to get rid of a plus 2yz from the left hand side, I'm going to minus a 2yz from both sides. So I have the z's on one side, the right hand side, and I have other terms on the left hand side. I'm going to factorize now the right hand side. So I'm going to factorize the z. So I have z on a bracket, and then 5xz divided by z is 5x. And then minus 2yz divided by z is minus 2y. Finally, I'm trying to get the z on its own, so I need to divide by what it's being multiplied by at the minute, which is 5x minus 2y. So to get rid of that 5x minus 2y, I need to divide both sides by 5x minus 2y. So on the left-hand side, I have 7xy divided by 5x minus 2y. And then obviously on the right-hand side, if you divide z on 5x minus 2y by 5x minus 2y, you're left with z. So it would have been fine to collect the z terms on the left-hand side, and just to really quickly down here show what that would have looked like, we would have had 2yz minus 5xz equals minus 7xy. I would have factorized my z to give me 2y minus 5x equals minus 7xy. And then finally I would have divided both sides by 2y minus 5x to give z is equal to minus 7xy over 2y minus 5x. And that's an equally valid solution. It's the exact same solution as this. They're equivalent fractions. It's just that all the signs are different. So it is a key point that sometimes when you're doing this type of a question, you may get an answer that is slightly different, especially sign-wise, than an answer you've seen somewhere else. And it could be just that you've collected your letters on one side and somebody else has collected the letters on another side. And so you essentially get the same answer, but just the signs might be different in that question. So we're just going to look at one further example without digging too much into this particular topic. So this is a question where we have to do what's called complete the square. Now, completing the square is manipulating a formula. So we are manipulating a formula, but we're not changing the subject of this formula. We have a formula that has y equals x squared minus 4x minus 10. So we can see that it's a quadratic formula. And we know that if we were to graph this particular quadratic formula, it would be a U-shaped function. Now what we're going to do is we're going to change the format of this formula so that it now is in the format y equals x plus h squared plus k. And there's a very good reason for doing this, and the reason is, so in this format, the minimum point of this curve is minus h k. So we're going to take whatever number is with the x in the bracket and we're going to change the sign. That's going to become the x coordinate of the minimum point, and then we keep the sign of the term that's outside of the bracket, or the number outside of the bracket, and that becomes the y coordinate, that minimum point. So there is a very good reason for manipulating this formula and changing it into this form. It allows us to read minimums or maximums, in this case a minimum. And so let's run through the process of that, and then in a further video we can look more deeply at how we actually go and complete the square and do lots of examples of that. So what we do in this question is we write down the x squared term as it is, and we write down the x term as it is. And then I'm going to leave a little bit of space and I'm going to put down the minus 10. So I haven't changed it at all yet. It's still in the form y equals x squared minus 4x minus 10. And what I'm going to do is I'm going to find a number to both add and subtract to this equation. Now how do I find that number? I take the coefficient of the x, minus 4, and I half it to give me minus 2, and I square it to give me 4. So again, I take the coefficient of the x, minus 4, I half it to give me minus 2, and I square it to give me 4. And so I'm going to add a 4 and subtract a 4 to this equation. Now, adding a 4 and subtracting a 4 isn't actually doing anything to the equation other than making it look different. So we're going to add a 4 and subtract a 4. Now the reason I do that is so that I have 3 terms here that I'll be able to factorize, and they'll give me a bracket squared. So let me show you what I mean by that. So I'm going to do 2 sets of brackets. I know that the first term in each bracket is going to be x and an x. The last term in each bracket is going to be a 2 and a 2. And to get minus 4x, I would need minus 2x minus 2x. Now we can see that x minus 2 on x minus 2 in the next line can become x minus 2 squared. The minus 10 minus the 4, I'm going to join them as well to give me minus 14. So on the next line I have x minus 2 by x minus 2 is x minus 2 all to be squared, and then I have the minus 14. And now we can see that this is in the format that I want, x plus h squared plus k. So we have x minus 2 squared minus 14. And so we've manipulated the right hand side of the formula to express it in this particular form. And just to finish this question, what would this be useful for? We change the sign of the number with the x in the bracket to give us a plus 2, and we keep the sign of the other number minus 14. And so if we were to have graphed the quadratic function y equals x squared minus 4x minus 10, this point here, the minimum point of that curve, is the point 2 minus 14. So just a bonus example there to show a manipulation of formula question where we didn't change the subject of the formula, but manipulated the right hand side to serve a particular purpose. In this case, the purpose of finding out what the minimum point of that curve would be. So let's have a look at some trickier examples taken from Leaving Cert higher level papers. Generally, this won't be a question in its own right on a Leaving Cert paper, but it will be an important step to be able to progress through a question, and that's definitely the case with the first few examples, where the maths is quite basic, but obviously we'll have to do some work to get to this stage in the question. So we're told that 4x plus 3y equals 12, 4x plus 3y equals 12, and we're asked to express y in terms of x. So this was taken from a coordinate geometry of the circle question, and we've been given this equation of a line, and we have to find y on its own. So first thing we're going to do is there's a 4x on the left hand side with the 3y, so we want to get rid of that by subtracting a 4x from both sides. So if I subtract the 4x from the left hand side, I'm just left with 3y, and then obviously if I subtract it from the right hand side, I get 12 minus 4x. I want to get the y on its own, so I'm going to divide by the number beside the y, which is 3. So if I divide both sides by 3, 3y divided by 3 is 1y, and then 12 minus 4x divided by 3 is just 12 minus 4x over 3. And so the actual maths in this sum is quite simple, but now we'll have to use this value for y to progress through the next part of this circle question. So example 2 has been adapted from an area, perimeter and volume question. We're given a formula that says that L is equal to r theta plus 2r, and L would stand for the length, r would stand for radius, and theta, when we see it, generally stands for the measure of an angle. So we want to express theta in terms of L and r. So I can see that theta is on the right hand side, so I'm going to leave it there, and to get rid of the plus 2r beside it, I'm going to subtract a 2r from both sides. So I get that L minus 2r is equal to r theta. To get the theta on its own now, I'm going to divide by the term next to the theta. R is being multiplied by theta, so I'm going to divide both sides by r. So I get L minus 2r divided by r equals, and r theta divided by r is just theta. And that's the final answer. If we wanted, we could split this into theta equals L over r minus 2r over r. And then to further simplify that, we could say L over r, and then minus 2r over r is just minus 2. So this answer over here is 100% fine, but again, depending on what you're going to use the value of theta for, it may be a good idea to split up the fraction, as we've done down in this example here. Example 3 is taken from a paper 1 question on finding the inverse of a function. So what we're going to do is we're going to express x in terms of y. At the minute, we're expressing y in terms of x. Y is equal to 3x minus 2. So the x term is positive on the right hand side, so I'm going to leave the x's on the right hand side, and to get rid of the minus 2 on the right hand side, I'm going to add a 2 to both sides. So y plus 2 equals 3x. And then to get x on its own, I'm going to divide both sides by the number next to x, which is 3. So we get y plus 2 over 3 is equal to 3x over 3, which is just x. Okay, example 4 has again been taken from an area, perimeter and volume question, and we're told that pi plus 2 on x plus 2y is equal to 12, and we're asked to express y in terms of x. So we want to make y the subject of the formula. So I'm going to keep the y's on the left hand side. We have this term here, pi plus 2 over x. I want to get rid of it from the left, so I'm going to subtract it from both sides. So subtracting it from the left gets rid of it from the left, and then subtracting it from the right, we have 2y equals 12 minus pi plus 2 on x. I'm trying to get y on its own, so I'm going to divide both sides by the number beside the y, which is 2. So 2y divided by 2 is just y, and then I have 12 minus pi plus 2 on x all over 2. So 4 fairly straightforward examples, but remember that these are in the context of a greater, more difficult question where originally we would have to form this equation, and then when we get our solution at the end, there's further work to be done with that. So we're just looking at how the manipulation of formula is really important as a step of a question. So question 5 is a question from financial maths, And this is a method that most people learn off by heart. So we have to manipulate or rearrange this formula, which at the minute is expressing P in terms of A, I, and T, and change it so that it expresses A in terms of P, I, and T. Now I'm just going to write down the formula slightly different just to save a bit of space as we work through the sum. So we have P equals A on 1 plus I on, now this 1 I'm just going to write as a fraction, 1 over 1, minus, where I have 1 over 1 plus I to the power of t, that's the same as 1 to the power of t, which is just 1, over 1 plus I to the power of t. And I close my bracket. And then that's all over. This 1 again, I'm just going to write as a fraction, 1 over 1, and then minus 1 over 1 plus I. Now I'm going to find two common denominators here. The first one is in the numerator inside the bracket. So my common denominator is going to be 1 plus I to the power of t, and that'll allow me to join these two fractions or express those as a single fraction. 1 into 1 plus I to the power of t is 1 plus I to the power of t, so I'm going to multiply 1 by 1 plus I to the power of t, minus 1 plus I to the power of t into 1 plus I to the power of t is 1, and I multiply that by 1, and then I close my bracket. I'm going to find a common denominator on the bottom as well. So I have a common denominator of 1 plus I. 1 into 1 plus I goes 1 plus I times, so I'm going to multiply 1 by 1 plus I. Minus 1 plus I into 1 plus I goes 1 time, and I'm going to multiply that by 1. So the numerator and the denominator both have this 1 plus I, and so we can cancel that. So we now have P equals A on 1 plus I to the power of t minus 1 all over 1 plus I to the power of t. And on the bottom we have 1 plus I minus 1. And 1 minus 1 is 0, so we just have I now on the bottom. Tidying this further, we'll go up here and we have P is equal to A on 1 plus I to the power of t minus 1 all over 1 plus I to the power of t. And then to divide by I, that's the same as multiplying by 1 over I. And so the next line becomes P equals A on 1 plus I to the power of t minus 1 over I times 1 plus I to the power of t. So remember, we're trying to get A on its own here. So to get rid of the denominator in the fraction beside it, I'm going to multiply both sides of this equation by I on 1 plus I to the power of t. That'll give me on the left hand side P on I on 1 plus I to the power of t. And that'll be equal to, on the right hand side, A on 1 plus I to the power of t minus 1. Finally, to get A on its own, I'm going to divide both sides by what's currently being multiplied by the A, which is 1 plus I to the power of t minus 1. So the left hand side now will become P on I on 1 plus I to the power of t all over 1 plus I to the power of t minus 1, and this is equal to A. And so we've expressed A in terms of P, I, and t. So this is called the amortization formula. And most people learn the derivation of this off by heart. But you can, like I said, if you're good at manipulating formula, rearranging formula, you can just start with the original expression, which is P in terms of A, I, and T, and through a good use of maths, work out A in terms of P, I, and T. So the wording of example 6 is quite tricky, but the maths on this first part of the question is quite easy. Let's read through the question. So we have gold jewellery is made from a gold alloy. That is a mixture of pure gold and other metals. The purity of the material is measured by its carat rating given by the following formula. So the carat rating of gold is 24 times m and then a little g. Those little letters are called subscripts. So this is 24 mg over mt. And the reason we might have subscript is just to show that mg and mt are different things. They're both based on mass, but one of them, mg, is the mass of gold in the material, and mt is the total mass of the material. And so if we want to find out what the carat rating of the material is, we multiply 24 by the mass of gold, and we divide that by the total mass of the material. Now what we want to do is we just want to rearrange this formula to express mg in terms of c and mt. At the minute we're expressing c in terms of mg and mt. So how are we going to do this? Well, the first thing is to get rid of the fraction. So I'm going to multiply both sides by the denominator of the fraction, which is mt. So I get c mt equals 24 mg. And then I'm trying to express mg in terms of c and mt. So I need to get rid of the number beside the mg. So I'm going to divide both sides by 24. So c mt over 24 equals, and 24 mg divided by 24 is just mg. So the math's quite simple. All we had to do was multiply both sides by mt and divide both sides by 24. But just the wording of the question and the notation had it a little bit difficult. And obviously there's more difficult parts in this question if you look at it on the exam paper. So in example 7, we are given that 2x plus 3y over x plus 6y equals 4 over 5, and we're asked to find the value of x over y. Now because we have one equation but two variables, it might initially seem like it's going to be difficult to find x over y, but we're not actually being asked to find the values of either x or y individually, just the value of x over y. And so this equation is possible, and we'll run through the steps on how we might do that. So the first thing I'm going to do is I'm actually going to cross multiply in this question. So I'm going to multiply 5 by 2x plus 3y, and then I'm going to multiply 4 by x plus 6y. So let's go and do that. So 5 times 2x plus 3y equals 4 on x plus 6y. And finding a common denominator in this question and then dropping the common denominator would achieve the same purpose. Multiplying out the brackets, we have 5 by 2x is 10x, 5 by 3y is 15y, equals 4 by x is 4x, and 4 by 6y is 24y. I'm going to collect the x terms on the left hand side of the equation, so 10x, and then to get rid of the 4x on the right hand side, I'm going to subtract the 4x from both sides. And I'm going to collect the y terms on the right hand side of the equation, so 24y is already on the right, and then to get rid of the plus 15y on the left, I'm going to subtract a 15y from both sides. Simplifying this further, we have 10x minus 4x is 6x, and we have 24y minus 15y is 9y. Now, it might seem difficult to see, well, how are we actually going to write x over y in this question? We won't be able to find what x is or what y is individually, but to find x over y, I can see that if I divided both sides of the equation by 6y, well, then I'll get an x over y on the left-hand side. So dividing by 6 will get rid of the 6, and then dividing by y will leave me with an x over y on the left-hand side. If I divide the left-hand side by 6y, I have to divide the right side by 6y. So as we've said, 6x over 6y would be x over y, and then 9y over 6y would be 9 over 6, and we could simplify that to give x over y is equal to 3 over 2. So example 8 has been taken from a topic on the Leaving Cert called integration. So it's a topic on Leaving Cert higher level maths. It's actually not on Leaving Cert ordinary level maths. And we've been given an equation x equals e to the power of 2y minus 1 over e to the power of 2y plus 1. And we've been asked to manipulate this equation so that e to the power of 2y is the subject of the formula. So the first thing I'm going to do is get rid of the fractions from the equation. So I'm going to multiply both sides by e to the 2y plus 1. So on the left hand side I have x on e to the 2y plus 1, and that will be equal to, on the right hand side, if I multiply it by e to the 2y plus 1, I'll get rid of the e to the 2y plus 1 in the denominator, and I'll be left with e to the 2y minus 1. I'm going to multiply out the left hand side, so I have x e to the 2y plus x, and that's equal to e to the 2y minus 1. Now you'll note that we have two occurrences of e to the 2y, and that's the subject of the formula. That's what I'm trying to get by itself. So there's going to have to be some factorization here. So the first thing is to bring them to the one side. So I'm going to leave x e to the 2y on the left hand side, and I'm going to subtract an e to the 2y from both sides to get rid of it from the right hand side. That's going to be equal to, so minus 1 is already on the right hand side, and then to get rid of the plus x from the left hand side, I'm going to subtract an x from both sides. I'm going to factorize the e to the power of 2i, and x on e to the power of 2i divided by e to the 2i is x, minus e to the 2i divided by e to the 2i is 1, and that's equal to minus 1 minus x. To get e to the 2i on its own, I can see that it's being multiplied by an x minus 1, so I'm going to divide both sides by x minus 1. So on the left hand side, that would leave me with e to the 2i, and on the right hand side, I would have minus 1 minus x over x minus 1. Now that's not quite in the format that they ask us for, so I'm going to factor a minus 1 from the top and the bottom. So on the top, I have minus 1 on 1 plus x, and on the bottom, if I take out a minus 1, I have minus 1 on minus x plus 1. So then I have e to the 2i equals, a minus over a minus is a plus, and so I have 1 plus x on the top, and minus x plus 1 on the bottom, or in other words, 1 minus x. And so now we've shown that e to the 2i is equal to 1 plus x over 1 minus x. So example 9 has been taken from a junior or higher level question. We're told that a squared equals bc squared plus a plus c all over b. And so the first thing I want to do is get rid of the fractions. I'm going to multiply both sides by b. That will give me on the left hand side a squared b, and on the right hand side bc squared plus a plus c. I'm trying to make b the subject of the formula, and so I'm going to collect all the b terms on the left. So I have a squared b, and to get the bc squared onto the left, I'm going to subtract a bc squared from both sides, equals, and then I have a plus c on the right hand side. So again, another example where we have two occurrences of the letter we're looking to make the subject of the formula. And so what we're going to do is we're going to factorize the left hand side. So I'm going to divide b into both of those terms. A squared b divided by b is a squared, minus bc squared divided by b is c squared, and that's equal to a plus c. So finally, I want to get b on its own, so I need to divide both sides by a squared minus c squared, which is being multiplied by the b. So we have b is equal to a plus c over a squared minus c squared. So we've made b the subject of the formula, but it's not quite in the format that they want the answer in. They want us to show that b is equal to 1 over a minus c. So what we're going to do is we're going to leave the top, a plus c, and we're going to factorize the bottom. We can see that this is the difference of two squares, a squared minus c squared. So I'm going to open up two sets of brackets, and I have a plus c on a minus c. And so I can see that if I divide a plus c into the top and the bottom, I'm left with 1 over a minus c. So b is equal to 1 over a minus c. Okay, our final question has been taken from a Leave Insert ordinary level paper. So it's a question where we want to do some rearranging, and then there'll be a substitution aspect to it then after that. So we're given that 8a minus 5b all over b is equal to c, and we want to make b the subject of the formula. Now I can see that there's two b's in this equation, so probably going to have to be some factorization later on. But the first thing I want to do is get rid of the fraction, and the way I'm going to get rid of the fraction is to multiply both sides by the denominator of the fraction, which is b. So multiplying the left hand side by b, I get 8a minus 5b, and multiplying the right hand side by b, I get bc. I'm trying to isolate the b, so I'm going to bring all the b terms to one side, and I can see if I bring them to the right hand side, they'll stay positive. So I'm going to keep the 8a on the left hand side of the equals, and then on the right hand side I have bc, and to get rid of the minus 5b on the left hand side, I'm going to add a 5b to both sides. So I have 8a, I'm going to factorize the right hand side by dividing b into both bc and 5b. So bc divided by b is c, plus 5b divided by b is 5. I'm trying to get b on its own, so I'm going to divide both sides by what's being multiplied by the b, which is c plus 5. So on the left hand side I have 8a divided by c plus 5, and that's equal to b on c plus 5 divided by c plus 5 is b. And so I've expressed b in terms of a and c. So the second part of the question involves us taking our equation with b as the subject, b is equal to 8a over c plus 5, and subbing in values for a and c. So b is equal to 8 on a is 2 to the power of 5 over 2 over c plus 5, and c is 3 to the power of 3 plus 5. Now it's going to be difficult to multiply the 8 by the 2 to the power of 5 over 2, so I'm going to change 8 into 2 to the power of 3, and then in the next step use the rules of indices to combine those two numbers. And that's over 3 cubed is 27 plus 5. So on the next line, I'm going to use the power of indices that says if the base number is the same, which is 2, we can add the powers. So we're going to add 3 plus 5 over 2. 3 is 6 over 2, and 6 over 2 plus 5 over 2 is 11 over 2. So using the rules of indices, I can multiply those two numbers and get 2 to the power of 11 over 2. 27 plus 5 is 32. People might spot here now that 32 is 2 to the power of 5, so we have b equals 2 to the power of 11 over 2 over 2 to the power of 5. And then again, using the rule of indices that says if we have a base number on the top of a fraction 2 and a base number on the bottom of the fraction 2, we can join them by subtracting the powers. And so b is equal to 2 to the power of 11 over 2 minus 5. Now 5 is 10 over 2, so 11 over 2 minus 10 over 2 is 1 over 2. And so our answer is b is equal to 2 to the power of a half. And again, using our rules of surds and indices, we can express that as root 2. A number to the power of the half is the same as the square root of that number. So if anyone wants any extra questions to practice, don't forget there is the attached pack of questions and work solutions from the past Junior Cert and Leaving Cert papers.